Alrighty then, corn children, children of the corn. It is a fine day for mathematics, and we are going to review parallel and perpendicular lines. This is a review, so I'm hoping all of this should look familiar. Yeah? Or not. Here we go. So, what do we have here? Well, I have drawn us a happy little picture. Look how nice that is. And you're going to notice that there are two lines, and they sure do look parallel, don't they? Parallel lines never intersect. The reason that they're going to be parallel and that they will never intersect is that their slopes are the same. Check this out. On this blue line here, we have a rise of 1 and a run of 2. It is an uphill slope, so it's positive. Where should I put it? Right here. So the slope here is positive 1/2. And the reason that this is parallel is that this line is also going to have the same rise and run. Let's see, here's a good dot. And here's another one. It's going to rise 1 and it's going to run 2. And that will keep these lines from ever crossing. So what's the big takeaway? When you have parallel lines, the slopes are equal. You can jot that down. That's the symbol for parallel. Yeah, parallel lines have equal slopes. It's true. Yeah, I know, right? So what about perpendicular lines? I'm glad you asked. Let's take a look. That doesn't really matter, but I am going to use this blue line, and I'm going to construct a line, and I'm not going to use the same slope. I'm actually going to use the opposite reciprocal slope. I'm going to take 1/2, reciprocate it, flip it over, and change the sign. This one is positive, so I'm going to use a negative slope. So I'm going to be using, where should I put it? Where should I put it? Up here, a slope of negative 2/1. That's your rise and your run. So from this dot, I'm going to rise 2, and I'm going to run 1 left. Yeah. And take a look. If I connect these, whoops, ignore that part. Not only do the blue and the green intersect, obviously, but they are intersecting at a right angle, which is the definition of a perpendicular line. So if the slopes are opposite reciprocals, opposite signs, flipped over numbers, then the lines are perpendicular. Yeah, we could write that down. I'm going to put it over here. Perpendicular, that's the symbol for perpendicular. Lines have opposite reciprocal slopes. It's true. Yeah, it is. So with these fun-filled facts, we can now look at another kind of a problem. Are you ready? Good, I'm glad you are. Get a clean paper. That one's got dots on it. All right, here's the problem. Write an equation of a line parallel to y equals 2/3 x minus 17 that passes through the point 6, -6, 3. Just made that up. Look at me, just made up a problem right like that. Okay, well, here's the deal. Some of you are still holding on with dear life to y equals mx plus b, and I'm not going to use that. Here's why I'm not going to use y equals mx plus b. I don't know the b of our new line. It's not stated openly. That is the b value of the other line, not the line I'm looking for. So instead, I'm going to use point-slope form of a line. It said write an equation. It didn't say write a specific kind of equation. Any kind you want. Point-slope form. Let's take a look at it again. y minus the y coordinate of a point equals m the slope times x minus the x coordinate of the point. All I need is a point and a slope. Well, okay, because look what we have. Here's a point on the line I'm looking for. This will be the x1, y1. This will be the point that I'll be plugging in. And what about the slope? Well, if it's parallel, it will have the same slope as this line. And this line is in slope-intercept form, so I know the slope has to be 2/3. Point, slope. All I have to do is plug these three things into this. What? I know. Check it out. Here we go. It's y minus, fill in the y coordinate. Boom. Equals, fill in the m, slope of 2/3. Boom. Times x, now this is going to be tricky, minus negative, whoop, whoop. Yeah, it's a plus, fill in the 6. I'm done. This is an equation that describes that line. It's parallel to this one, notice they have the same slope, and it has the correct point value in it. Now, if you want to get all fancy schmancy, you could distribute and you could move the -3 to the other side and turn it into slope-intercept form, but I don't feel like you have to. I know, okay. All right, let's try another one. This time, let's write an equation of a line perpendicular to y equals 3x minus 4 that passes through I'll make up a point. How about 1, -8? Just for fun. I know, right? Well, once again, I am not attached at the hip to slope-intercept form. I really like point-slope form. Let me slide that up so we can see a little bit better. All right, if I want to use point-slope form, all I need, oh man, is to write it down correctly. Let's try that again. Y minus y1, mx minus x1. All I need is a point and the right slope. Well, there's your point. This is your x1. This is your y1. Now what about your slope? Okay, well, our slope needs to be perpendicular to this line. Well, what is the slope of this line? The slope of this line is 3, also known as 3/1, also known as positive 3/1. So what slope should we use? I'm thinking we should use the opposite reciprocal slope. So the slope we're going to be using is not this one. No. We are going to be using opposite sign, reciprocal value. Hey, point, slope. I know. Plug and chug, people. All right, y, I'll do it slowly this time, minus the y coordinate, see the minus negative now, equals the correct slope, x minus the x coordinate. Really, the only thing that I would do here, I don't feel the need to rearrange and solve and all that, is I would turn that into a plus just because it looks pretty. And I'm all about things that are pretty. Really, come on. All right, hope you enjoyed that festive review of parallel and perpendicular lines.